Record. Go for it.
Cool. Hey Mark, congrats on the upcoming keynote at TDWI. Your keynote is on an architecture for the age of data analytics. What's happening, what's changing, and what's the topic about?
I guess just you can cut in between.
Yeah.
You want me to look at a camera, or you want me to keep focused on him?
Just conversation, and then we'll edit all of his questions out. So it'll just kind of be you
Okay.
talking off screen.
So
talk
your
towards
questions,
him.
if you'll sort of deal with the question and your answer,
Yep.
then we're going to superimpose the question on the screen.
Yeah, I just didn't know where you want me to face.
I think sort of looking more or less
yeah.
towards me.
Yep.
All right.
Your keynote is on an architecture for the age of data analytics. What's changing? What are you going to be telling us about?
I'll be talking about three different things. Architecture, first of all, because architecture, people usually think of code, right? Architecture is this module and that piece of code and that piece of code. And in the data warehouse world, it ends up being products. There's an ETL product and a database and a BI tool. The big data people, it's all about, this piece of Hadoop and Spark and these other things, but the reality is that architecture is more than just code. So trying to get past this point of what architecture is thought of and what it really is, because it goes back to how a data warehouse developed in the first place, or the things that came before. The second piece, after kind of going through architecture, is just a key element that's been ignored by the data warehouse people, surprisingly, and is non-existent in the big data world, and that's data architecture. Data architecture is more than data models, and it's more than a database or a Hadoop file system. So trying to work through that and understand what data architecture means and how that's changed, because one of the big things that you'll see, whether Hadoop and other big data technologies were here or not, is business intelligence tool architectures have changed. The actual way that they work has changed. And they force changes into data architecture, and that has not been recognized by the data warehouse community either. And then the third thing is something that goes back a long way, and that's how we develop. If you think about agile methods, they're a part of an answer, but they're not really the whole answer. So how you organize people and orchestrate the processes that people work within, and how we do our work, those things are also changing. So those are kind of the 3 points of the presentation.
And how do you see data warehouse automation in general and Warescape in specific fitting into this new architecture?
Warehouse automation, if you take it as sort of a bigger item, you're not really just, here's a data warehouse, let's automate all the pieces of it, but you think about it in a broader context. There are a lot of things that we do that require orchestration, and that orchestration is slow and painful. When I manage data warehouses and analytics teams, a lot of the work we did was manual, and a lot of the work we did because of deficiencies in the tools and the infrastructure that we have. So we do things that quite simply can't be automated. So there's a pass off from this person to this person, and then from this person to this person, and you spend your entire weekend doing a data warehouse update. And so that's risky because you're doing these things. If it fails, you have to fold it back. If it fails and you don't catch it, then everybody's not working the next day. That kind of stuff is really a big part of the managerial risk that we always ran. And so how did we solve that? Well, usually we solved it by doing monthly or more likely quarterly releases of data and front ends and things like that, because of the complexity involved. And that's just a legacy of 20-year-old architecture. So if we rethink how we execute that and how we automate that, we can cycle things a lot faster. And so that plays into some of the agile side of it. It plays into old and new architectures.
Very good. You were one of the early data warehouse experts to recognize the big data, the kind of impact that big data would have on our industry. What have we done right so far in trying to integrate, manage, incorporate big data into warehouse type infrastructures?
Yeah, the history there is kind of interesting because you almost see it replaying itself again. When we started doing data warehouses in the early 90s, what we were building looked a lot like the mainframe reporting systems we had before. You know, there was a relational database, it sat on a single big computer, a bunch of reporting stuff was hooked up to it. What was different though was the architecture. You know, there was this single system time-shared model on a mainframe, not that much different from single system Unix machine running a relational database, but how you designed the data models, how you populated the data, how you thought about designing it was completely different. And that was really hard to get across. That's why it took 10 years for data warehousing to catch on. And people forget it took 10 years for this to be considered actually a good idea. We went through an early phase of look at this great stuff certain companies are doing and look at how much value there is, to a lot of people trying it and failing, and everybody, you know, coming down off of that high and saying this costs more, it takes new technology, we don't have the skills, and maybe this isn't worth it, to finally figuring out that in fact, yeah, there is value there, here's how to do it, here's the architecture for it, here's the methodology that goes with it. Once all of those pieces lined up, it really took off again in the, I'd say the late 90s, where really the money got made as the whole market expanded. And the big data market, you see the same things. You had a set of technologies that evolved in one set of circumstances, you know, big batch global search index building. But it turns out that that big batch data processing work is kind of important for a lot of things. And the technologies that developed to do it could do it cheaper and faster and more easily, in the same way that modern Unix-based relational databases could do a much better, cheaper, faster job than the old mainframes could. And so you have a technology shift, but it's taken quite a while for people to realize that there's more to it than just this one component. There's a whole raft of pieces that have to be stitched together to build the kind of data infrastructure that a modern company wants.
And so maybe you just addressed that, but what have we just done horribly wrong as it relates to try to deal with big data?
I don't think we've done anything horribly wrong. If you think about big data, you know, there was the VLDB conference actually started in the 1980s. And then, you know, now there's an XLDB conference, but it's the Insiders Conference on high-scale systems. And, you know, the technology goes through a period, and so the things that we get wrong is that we think about a lot of this stuff as a technology problem. It's not a technology problem. There's a technology enabler, and maybe it's slightly different, but the usual thought is throw out everything you had before and start fresh. We made that mistake with data warehouses. We threw a lot of things out we should not have thrown out. Transaction processing systems that we designed for mainframes, and the ones we designed for Unix, and then the ones we designed for the web. They weren't really wholesale replacements, they were keep about 50%, throw about 50% away. And when you look at data warehousing, we kind of forgot some things. You know, we got dogmatic about data models, and that has relaxed. Remember the old Inman-Kimball wars of the mid-90s of you must do dimensional modeling, or you must do third normal form, or fifth normal form, or whatever it is. And then the methodologies of top-down versus bottom-up, or you know, however you want to approach it, that went with those things. Everybody just assumed that was the way. And then once we kind of stabilized on a set of approaches for data modeling and requirements gathering and building interfaces, we stuck with it, and we didn't change anything. You look at where I started in 1992-93, computer systems are about 15,000 times more powerful than they were before. With all of that extra power, we haven't done very much. We have inefficient tooling that hasn't evolved. We still build ETL tools the same way we built ETL tools in 1993. I mean, it's not much different. It's kind of crazy to be approaching the problem the same way. So, you know, you asked about data warehouse automation earlier. Why is it that I have to go through these 12 steps when a computer can fully automate all of those 12 steps? Because it knows exactly what I need to do, and I just have to choose which of the 3 options I want out of that. That's the kind of thing that computer power should be used for, instead of making people do rote, repetitive, error-prone work. And so I think, it's time for a change there.
Fantastic. I think that transitions well into the concept of automation. I know you just addressed a bunch of it, but where do you see just the real obvious no-brainers where automation can help in the development of a warehouse or a strategic application?
I think automation comes in a lot of forms because, when you think about, if you called it data warehouse automation, the problem is that then you immediately think of the data warehouse and just automating ETL or filling data models or delivering reports or whatever it is. Data warehouse has moved well beyond that, though. The data warehouse as reporting system was something we really needed in the mid-90s because we didn't have anything. We had single application reporting systems, or reporting systems where we dumped a bunch of data and then wrote a bunch of code that generated reports, and that was the mainframe reporting world, or the early relational world. Since then, it's been incorporated into a lot of things. We understood how to use information as an organization. When I started, we could do top 10 retail reports and everybody was really excited. And now you have to supply statistics and proper trend detection and forecasting and anomaly detection against that data. We've moved from here's some data, eyeball it, to now we need to actually apply math to it and then make decisions off of the things that come out of that, or explore it in more detail and understand what's going on. And so we've moved it into operations. Data isn't just generating reports on one hand because we have transaction systems on the other hand. And a lot of the automation frameworks aren't just about automate your ETL and automate your BI. They're now about automate an entire process of data from production to consumption. And to do that requires thinking about how it works in operations. A lot of the big data work is really about near real-time flowing data, and it's about event stream data that surrounds a transaction. So, we go into a grocery store and we scan out at the register, there's a ticket with a bunch of stuff. That was the 1990s. Now we have everything that happens from the point where you were marketed to, or where you showed up in a grocery store, and which things you selected out of a whole raft of choices, right down to video feeds of the path people take through the store to figure out where they spend most of their time. That's all automated now, or automatable. And so it begins to move out towards the business side of not just which data do you need, but what are you trying to accomplish and what process are you trying to maybe automate? And then working backwards from that. And that encompasses a lot more than just get data from here and put it into a database. It encompasses the algorithms and the front ends and the back ends and all the points in between.
Excellent. There seems to be a lot of synergy between automation, whether it's for the warehouse or of data applications, and agile type methodologies, and those two sort of working in concert. Why is that? Where do you see sort of the complementary pieces there?
Yeah, automation and agile are, they are complementary, but they can also work against each other, and that's one of the real hard parts. Agile as a methodology really came out of having somewhat stable infrastructure in the transaction processing world. And the fact was that we're turning features on websites very quickly, and we need a way to develop applications where one feature doesn't hold back other features. And so being able to compartmentalize things. In the developer world, it's now all about services and microservices and lean methods or agile methods and something called DevOps, which is just about tying operations, the running of systems, with the development of code. Because historically what's been happening, and it's been happening with the early agile movement, is developers write code, chuck it over the fence, operations picks it up, and it is a nightmare to maintain and operate. So these guys write unmaintainable code, essentially. You can have your features, but it takes 3 times as many people to run the systems that support them as it should. And so part of the impetus to automate things is to remove some of the human element out of the operations side. But the other part is that if the operations piece and the work that developers do to, say, provision and deliver data is done on the same infrastructure, you can turn things a lot faster, which is a key piece of Agile, is just getting speed by removing inefficiency, by removing human work that humans don't need to do, by approaching things in smaller pieces. And so your ability to do that requires an infrastructure that isn't heavily manual. And so automation and Agile in that sense really fit well together. I think there's a second piece to the whole Agile and automation as well, which is once you've automated things, you have a pretty well-defined process for it. And it enables you to actually step back and look at your process and say, maybe there's a different way to do this process that's more efficient. So maybe we can take this process, which takes, I don't know, 6 hours or a day or whatever it takes, throw it out and introduce a totally different process. But under the old sort of architecture or way of doing things, if you had to do that, you would have to spend a lot of development effort rebuilding a lot of the core building blocks to get up there. When you have automatable tooling and infrastructure, you can reuse those components and redefine a process over top of them much more quickly. And I think the automation and Agile comes into it from that perspective as well. So you have both an operational component and a development component that feed into it.
Fantastic. Let's end with a couple of things about best practices. So give me some, you have a long history in data warehouse development. What are some best practices or must-haves for people developing their first warehouse, people resurrecting one? What are some just slam dunks that people should put into the process of successful data warehouse development?
I think a key thing is just understanding where in an organizational maturity curve you live. You know, I've worked at companies that were extremely advanced.
Sorry. Wow, man, that phone never rings. Yeah, I just hung up too. Sorry about that.
You're good.
You just start that one again
Yeah,
after the answering machines go.
really. Data warehouse development best practices. What are just some slam dunks or things that folks need to fold into their program?
I think that it's kind of hard with best practices, especially right now, because you know there's a point in the market. Early on, there are no best practices because we're still figuring things out. That's where we were really from the late 80s through to the mid to late 90s. And then we kind of figured out all the pieces, and you could begin to routinize things and say, well, if you want this kind of a result, here's how you should approach it. You know, that's where a lot of the data modeling methodologies came from and other pieces. And then you get into a late stage of the market and it all becomes productized and you can almost take things off the shelf. And so it really, the best practices today depend on where you sit with the kind of infrastructure and projects that you're building and where the business is with its use of data. I've worked at companies that were really sophisticated. We had a statistics team, you know, operations research, we had a whole lot of analysts, we had BI people, and then I've worked at the other end of the spectrum with nothing. And a lot of people think that you can just jump from nothing to I'm doing high-end statistical modeling and I'm doing forecasting and I'm automating everything, and it just doesn't work that way. Because there's a lot of process and how people use information that just hasn't been internalized. And so best practices for somebody who has never done it before or who's coming into it kind of late, or like you said, rebooting a data warehouse that maybe wasn't doing its job, you know, over the last 5-6 years. There you're starting with the basics, you know, getting the infrastructure right, making sure that you have the tooling to just simply and repeatedly deliver data on a daily basis and store and manage that data and not have weird performance anomalies where one day things are great and the next day things are 6 hours late. And a lot of that is the basic blocking and tackling of BI. And I would say you could pick up 10-year-old books on data warehousing and go right from there. You know, whether you chose Inman's model or Kimball's model or whatever, this idea that we can throw things out, buy a BI tool, ignore a data mart or a data warehouse, that's a pipe dream. You need the infrastructure there, but you may not have to build it the way we built it before. When you get into the more advanced things, the best practices shift, because now you're at a level of maturity where you've done all of those things, and each incremental piece of effort gets you less and less. And so that's where people have started really 6-7 years ago to break away from the old ways of doing things. And the old ways of doing things involved a lot of upfront work and a lot of modeling, because it presupposed the problem. The problem is reporting, the problem is monitoring, and it's human eyeballs on data. When you start automating things to let machines do the anomaly detection and just tell you when something is either extra good or extra bad, at that point you need different tooling, because now you're inserting algorithms into data pipelines and saying, only tell me when this is good or bad. But in order to do that, you have to build up a level of statistical or machine learning knowledge. You have to have the data in forms that it can support that, and you have to have the tools for the people who need to do that kind of work to do it. It's not as simple as buy a tool, stick it on my data warehouse, and I now have analytics. It's much deeper than that, because it takes human skill, different data pipelines than the data warehouse provides, and potentially different data. In fact, most of the time different data. And so those things lead you to kind of a different set of best practices for analytics.
How about in closing, what are just some no-nos? What should folks just avoid, and that will help them in the road to success?
In the BI world, a lot of that is just going with fashion, because the market, whether we like it or not, is driven by fads. And sometimes the fads stick and become something, and sometimes they don't. Hadoop started out as a fad, and it did one thing, and it did it really well. And the good and the bad of that is that people jumped on that fad and tried to replace large-scale databases with it. That doesn't really work that well. It takes a long time to mature that sort of technology, and the misapplication led to a lot of failures. But the other side of that fad is that there was a real core to it, and that real core led to the development of technology to do things that we could never do before. But what happens is people approach it dogmatically. They say, oh, we have to throw out this entire set of things we have and bring in something new, and we'll start from scratch and we'll build it all up. That really doesn't work. There are data management practices that people forget about. The idea of having data models. What's happening now in a lot of the big data world is the discovery that you do actually need data models, because somebody has to somehow connect to that data and understand it, and writing a program for every single thing you want to do is not really the right thing. So there's a technology component that's going to come in whether you like it or not in the BI world, and there's a piece that says, a lot of these data management practices we had, they're equally important now. Master data management sounds like a bad word to a big data person, but in fact most of the failures have been driven by really poor master data management. And so the no-nos are just not thinking and going wholesale into things because it seems like the right thing to do. The flip side of it is what a lot of data warehouse people have been doing for the last 7-8 years now. Head in the sand. This big data stuff's a fad. It's going to blow over, we don't have to pay attention to it, because it's all data and we have databases and they work great. And it turns out that databases work great when you're doing BI and you're writing queries and it's nicely fixed into a data model. When your questions change day by day by day, you can't use that. It doesn't work. So you have to think about different tools for analyzing data. You have to think about the fact that time series analysis of event feeds is not the same thing as querying transactions. And those two things lead you on different roads. And so you really have to go back to basics and think about the problem you're trying to solve and whether or not the technology and the process and the organization you have is going to get you there, because it's no longer a one-stop shop.
Perfect.